All right, let's kick things off with a really simple idea. On the one hand, you've got chaos. On the other, you've got order. See, raw data in its natural state is total chaos, but useful information, that's order. So in this explainer, we're going to follow the incredible journey that transforms that chaos into order.
I mean, seriously, think about it for a second. You tap a button on your phone, and a few minutes later, a perfectly made coffee is waiting for you with your name on it. But behind that super simple tap is this massive, high-speed journey of data. Let's map out exactly how that whole journey works.
Okay, so where does a journey like that even begin? Well, it starts with a plan. Just like you wouldn't build a house without a blueprint, you can't build anything with data without a blueprint either.
And right here, this is the fundamental problem we have to solve. Raw data is just a jumble, a total mess of facts and figures. It's like someone just dumped a pile of bricks, wood, and wires in your front yard. You can't live in that, right? To turn all that chaos into something you can actually use, you have to give it structure. You need that plan.
So that plan, we call it a data model, and it's basically a set of rules that defines how different pieces of data relate to each other. For instance, the model says a customer has a name and an order history, and an order has a list of items and a price. It's the thing that brings logic to the chaos.
And these blueprints, they're not just one single thing. They've got layers. You start high level, right, with the conceptual model. Think of it like a quick sketch on a napkin, just a big idea. Then you get more detailed with the logical model. That's like the architect's formal schematics. And finally, you have the physical model, which spells out exactly how that data is going to be stored on a computer, right down to the nitty-gritty details.
Okay, so we've got our physical blueprint locked in. But now we have to ask, what language are we going to write this in? And how we're going to send the message from one place to another? You know that physical data model we just mentioned? Well, in the real world, that basically translates to a file format. It's a common language, a set of rules that both the sender and the receiver agree on. That way, when one computer sends a chunk of data, the other one knows exactly how to read and understand it. No confusion.
So let's look at two super popular languages for data. Over on the left, you've got CSV. It's simple, it looks like a cable, perfect for something like a spreadsheet. Now look over at JSON on the right. See the difference? It's way more descriptive. It can handle these complex, nested structures, kind of like a digital contact card. That flexibility is exactly why JSON is used all over the web today.
All right, so we've got our data structured, it's written in a language computers can understand, but how does your coffee app on your phone actually get the menu from the cafe's computer system? It doesn't just, reach out and grab it. No, it sends a request through a special kind of messenger. And that messenger, that's what we call an API, an application programming interface. A really common type, a REST API, works exactly like a waiter in a restaurant. Your app, the client, tells the API what it wants. The API then goes to the server, which is like the kitchen, gets the order and brings it back, usually in that nice, organized JSON format. It's the essential middleman making the whole conversation possible.
So we've got the blueprint, the language, and the messenger, but to handle millions of coffee orders, you can't just have one person running around. You need a factory. You need a data assembly line.
At its core, a data processing pipeline is pretty much a black box. You feed raw data in one end, from files, databases, those API calls we just talked about, and then on the other end, out comes valuable information, knowledge, and intelligence. Things like dashboards, sales reports, and real-time updates.
Okay, so let's crack open that black box and see what's happening inside. Data moves down this assembly line, right? It starts at ingestion. That's where all the raw materials arrive. Then it goes into storage. After that comes computation, which is where the real transformation happens. And finally, it reaches the serving layer, where the finished product is all ready to go.
All right, but for me, the most fascinating part of this whole thing is what happens on that factory floor, that computation stage. Because, as it turns out, not all data is processed in the same way. So you've really got two main ways of doing things here. The first is batch processing. Think of it like saving up all your laundry for one big wash day on Sunday. You collect a giant pile, then do it all in one huge load. Stream processing, on the other hand, is like washing each dish the moment you're done using it. It's immediate, it's continuous. Let's break down batch processing first. It's very methodical, very deliberate. You wait for some kind of trigger, like, say, the end of the business day. Then you bundle up all the data from that day, process it in one massive job, and store the final result. This is the classic world of big data systems, and it's absolutely perfect for things like a daily sales report.
Stream processing, though, is a completely different way of thinking. Just picture a conveyor belt that never, ever stops. Data flows in continuously and gets processed immediately, in real time as it arrives. This is essential for things where you need the info right now, like detecting credit card fraud or tracking a delivery driver on a map.
But here is the billion-dollar question for any big tech company. What happens when your app goes viral? When you suddenly have 10 times or 100 times more data than you planned for? What happens when your factory floor is completely overwhelmed? Well, you have to scale.
And you've basically got two options. Vertical scaling is where you just replace your machine with a bigger, faster, more powerful, and way more expensive one. But horizontal scaling is different. You just buy a bunch more standard, off-the-shelf machines and spread the work across all of them. This approach is cheaper, it's more resilient, because if one machine fails, the others just pick up the slack, and it's incredibly flexible. This idea right here is the secret sauce for how the modern internet handles such an insane amount of traffic.
So there you have it. From the blueprint, to the language, to the messenger, all the way to the factory floor. That's the journey of data. The next time you order that coffee or stream a movie or check the weather, you'll know about the incredible invisible data assembly line working behind the scenes. So the real question is, what other data factories are quietly powering your life right this second?